Okay, now we have the new positions of all the particles in the first iteration. Let's take a look at both their positions in the initialization phase and the first iteration. Although we still have a long way to go to reach the optimal solution, this image illustrates the tendency of the particles to approach the center of the contour. Let's move on to the flowchart. After updating the positions of all the particles, we need to calculate the cost for each particle. The cost of each particle is calculated using the cost function, in other words, the sphere function. By inserting the position of each particle into the sphere function, its cost is calculated. This process is repeated for all particles. These values indicate that the best or lowest cost belongs to the fifth particle. Okay, let's move on to the flowchart. At this point, we have reached the end of the PSO loop, and we need to check whether to continue. The termination condition in our problem is reaching a specific number of iterations. Since we are in the first iteration and max ITR is set to 50, we need to continue. The first step in the next iteration is to update the best personal experience for each particle and determine the global best. We initialize these values by reviewing the state of each particle up to this point. Let's proceed with that. The position and the associated cost for each particle over the past 2 iterations are summarized in the following table. We begin with the first particle. The best experience for the first particle comes from the initialization step, or 0 iteration, as it resulted in a lower cost, meaning it is closer to the origin. We will apply the same process to the remaining particles to update the personal best for all of them. As previously established, the global best is assigned to the fifth particle, which has the lowest cost. According to the algorithm flowchart, it is now time to determine the next position of the particles. First, the velocity is updated using the well-known PSO velocity update equation. By substituting the parameter values of all 3 components and summing these 3 vectors, the new velocity value is calculated. Let's review this process together. Hey guard, thanks for your attention. Okay, now we can calculate the new position using this updated velocity. We simply need to add the position vector from the previous iteration to the new velocity vector. Because this value is within the allowed range, it is confirmed by the guard. So, the first particle will be positioned here in the second iteration. Now, let's move on to the second particle. We begin again with a velocity update, which is the vector sum of the 3 vectors. Momentum vector, cognitive component vector, and the social component vector. The new velocity value is outside the allowed range, so we need to correct it. Now, with this modified value, let's proceed to update the position. We simply need to add the position vector from the previous iteration to the new velocity vector. Since this value is within the allowed range, it is confirmed by the guard. So, the second particle will be positioned here in the second iteration. Now let's move on to the next particle. Here we have the velocity and position values of the red particle from the first iteration. Let's explore how they change in the second iteration. Let's go watch the velocity update process. Okay, now it's time to update the position. Let's go take a look. Yes, guard is right. Everything is okay. So, the third particle will be positioned here in the second iteration. Now let's move on to the fourth particle. Here we have the previous state of fourth particle, and we are looking to estimate its next state. In the second iteration, the velocity of the fourth particle is updated by following the PSO velocity update equation. Let's go and see the operation of updating the fourth particle. The guard informs us that the obtained velocity value is outside the range of -3 to 3. Alright, let's adjust it to bring it within the allowed range. The new velocity value is moved here. Now we calculate the new position with this updated value. Based on the position update equation, the new value is calculated. Let's take a look. Since it is within the permissible range, we accept it. This way, the position of the fourth particle is now moved here. Now, let's move on to the fifth particle. In the previous iteration, the fifth particle, which also owned the global best, was at this position. To find the next state, let's first look at the velocity update. The new velocity value is passed here, and we can calculate the new position using this updated velocity. Let's take a look. Since it is within the permissible range, we accept it. As a result, the position of the last particle is now moved here. Okay, now we have the new positions of all the particles in the second iteration.